We have integral of rational function. First, let me copy our denominator. We have s to 4 power plus 6s squared plus 25. We can rewrite this to form s squared plus 5 because we have s to 4 power and 25 at the end. So we can put to second power. And now when we take s squared plus 5 to second power, we will have s to 4 power plus 2 times 5s squared. So we have 10s squared. And here we have only 6x squared. So we have to subtract 4s squared. And now left side is equal to the right side. We can rewrite this to form s squared plus 5 to second power minus, so we can put 2s to second power. So now we can use form that a squared b squared is equal a plus b times a minus b. So this is equal, we will have s squared plus 5, this is our a, and we have plus first 2s, and next we have s squared plus 5 minus 2s. We can rewrite this, so this is equal s squared plus 2s plus 5 times s squared minus 2s plus 5. Now we have to check discriminant. So is our delta is equal b squared minus 4ac. So it will be 4 minus 4 times 5 is 20. So our delta is equal negative 16, is less than 0. So first expression we can not factorize because this is quadratic function. Discriminant is less than 0, so we don't have real solutions. And the second, let's check, we have delta is equal b squared, so we have 4 minus, the same situation like here will be minus 20. So delta is equal negative 16 is less than 0. So we don't have real solutions. So we cannot factorize the second expression. It means we can rewrite our, let me rewrite this integral one more time. We have integral, I can put 1 over s to 4 power plus 6s squared plus 25 with respect to s. So now I can rewrite our rational fraction to sum of partial fractions because we factorize our denominator. This is our denominator now. We have 1 over s squared plus 2s plus 5 times s squared minus 2s plus 5. So this is identically equal to, and denominator will be first s squared plus 2s plus 5 plus, and second denominator will be s squared minus 2s plus 5. We have in denominator second degree, so in numerator we have to have first degree, so it will be a s plus b, and we will have cs plus d. So now to reduce this fraction we will multiply both sides of our equation by s squared plus 2s plus 5 times s squared minus 2s plus 5. So the numerator on the left side will reduce and we will have only 1 is identically equal to, and when we multiply first expression by this whole part, denominator will reduce and we will have as plus b times s squared minus 2s plus 5 plus, in the second fraction, the numerator s squared minus 2s plus 5 will reduce and we will have only cs plus d times s squared plus 2s plus 5. So now we have to do multiplication. So on the left side we have 1 is identically equal to, we will have as cubed minus 2as squared plus 5as. Now will be plus bs squared minus 2bs plus 5b. And we have in the second expression will be plus cs cubed plus we have now 2cs squared and we will have plus 5cs plus ds squared plus 2ds plus 5d. Now we have to compare the like terms. So we have 1 is identically equal to, we have s cubed. So we have a plus c times s cubed. And next s squared will be, so we have x squared in this expression. So we have plus, I can put, and in parentheses I will put negative 2a plus b plus 2c plus d times s squared. Next we have expression with s, so will be plus 5a minus 2b plus 5c plus 2d and times s of course, and what we have plus 5b plus 5d. We now compare the coefficients of s cubed on both sides first. So we have s cubed. On the left side we don't have, so it means this is equal 0. And we have a plus c. So we can write that a is equal negative c. Now we have to compare the coefficients of s squared. We don't have on the left side, so it means the coefficient is 0 and this is equal. We have negative 2a plus b plus 2c plus d. We have a equals negative c, so we can substitute this. So we will have 0 is equal negative 2 times negative c, so will be positive 2c plus b plus 2c plus d. So we can write that this is equal 2c plus 2c is 4c plus b plus d is equal 0. I just change the sides and add the like term. So next we have to compare coefficients of s. So on the left side we don't have s, so it means this is equal to 0. And on the right side we have 5a minus 2b plus 5c plus 2d. So we can substitute a by negative c, so we will have, and I will change the sides, so it will be negative 5c plus 2b plus 5c plus 2d is equal 0. 5c and negative 5c we can reduce. And we have that 2, I forgot we have negative 2b, of course. We have negative 2b plus 2d is equal 0. I will move negative 2b to the right side, so we will have 2d is equal to b. Now we divide both sides by 2, so we have d is equal b. So next, we have to compare constant. We have on the left side 1 and on the right side is 5b plus 5d. So we have that d is equal b. So we can rewrite that this is equal 1 is equal 5 times b plus 5b. I just substitute d by b. So we have that 1 is equal 10b. We divide both sides by 10, so b is equal 1 over 10. It means d is equal the same 1 over 10. Next, we have to find c and a. So let's substitute b and d to this equation. So we will have 4c plus, we have 1 over 10 plus 1 over 10, so it will be 2 over 10 is equal 0. I will move this to the right side, so will be, let me put this here. We will have 4c is equal negative 2 over 10. Now I will divide by 4 both sides. So we have c is equal negative 2 over 40. So c is equal negative 1 over 20. We have c. So a is equal negative c. So we have that a is equal 1 over 20. So now we can rewrite our integral of rational function to sum of partial fractions. This is equal integral of, we have ac plus ba is equal 1 over 20, s plus b is equal 1 over 10 over, we have s squared plus 2s plus 5, and we have plus negative 120 s plus d is 1 over 10 over s squared minus 2s plus 5. With respect to s, we have integral, so this is equal. We have integral of sum, so we can change this to sum of integrals. We will have integral of 1 over 20s plus 1 over 10 over s squared plus 2s plus 5 with respect to s plus integral of negative 120s plus 1 over s squared minus 2s plus 5 with respect to s. So we have to solve these two integrals. To solve these integrals, we have to first find derivative of our denominator, because we have second degree in the denominator and in the numerator we have first degree expression. So we will find derivative of our denominator. So let me divide this page to 2. On the left side we will solve first integral. We have to find derivative of s squared plus 2s plus 5. This is equal to s plus 2. So now I will divide numerator by derivative of denominator. So we have 1 over 20s plus 1 over 10. We will divide by derivative of denominator, so by 2s plus 2. 1 over 20s divided by 2s is 1 over 40. Now 1 over 40 times 2s is 1 over 20 s. 1 over 40 times 2 is plus 2 over 4, so is 1 over 20. So now we have to subtract. First expression will reduce. 1 over 10 minus 1 over 20, we need to have the same denominator, so we multiply by 2 numerator and denominator, so we will have 2 over 20 minus 1 over 20, so is 1 over 20. So now we can rewrite our first integral, and we will have that this is equal integral of numerator will be 1 over 40 times 2s plus 2 plus 1 over 20. When you add these two expressions, we will get the same what we have at the beginning here. Over denominator we have to just copy. We have s squared plus 2s plus 5 with respect to s. So this is equal. We can rewrite this expression to two fractions. So we will have integral of 1 over 40 2s plus 2 over s squared plus 2s plus 5 plus, and we can divide to two integrals, so it will be with respect to s, and integral of 1 over 20 over s squared plus 2s plus 5 with respect to s. So this is equal 1 over 4 we can take before integral, and what else? Now we have in numerator derivative of denominator, so this is equal natural logarithm of absolute value of s squared plus 2s plus 5. The constant we will add at the end, and next we have plus 1 over 20 we can take before integral, so we have 1 over 20, and we will have integral 1 over s squared plus 2s plus 5 with respect to s. This is equal. First we have to copy first expression, so we have 1 over 40 natural logarithm of s squared plus 2s plus 5, and we have plus 1 over 20, and we will rewrite our denominator. We will have s plus 1 to second power plus 4. Let's check. We will have s plus 1 to second power is s squared plus 2s, and we will have plus 1, and plus 4 give us 5, so everything is okay with respect to s integral. So now we will substitute s plus 1, that this is equal u, and because we need to reduce this 4, so I will put square root of 4. Now we have to find derivative of both sides of our equation, so we will have that 1 is equal square root of 4 is 2 du to ds. Now we multiply both sides by ds, so we have that ds is equal to du, and we can rewrite first expression. So we have this is equal 1 over 40 natural logarithm. because s squared plus 2s plus 5 is positive always, because coefficient before s is 1, so we have parabola open up and we don't have roots. So value of our expression in absolute value bars is always positive, so we don't need to put absolute value bars. We can put this in parentheses, s squared plus 2s plus 5, and we have plus, now we have 1 over 20, and we have integral of ds is equal to du over, and s plus 1 we have to replace by square root of 4u to second power plus 4. So this is equal, first expression we will rewrite 1 over 40 natural logarithm of s squared plus 2s plus 5, plus we have 1 over 20, and we have integral of 2 du over square root of 4 to second power, so we have, so will be 4u squared plus 4. Now we can factorize 4 in denominator. First expression we have to copy. We have 1 over 40 natural logarithm of s squared plus 2s plus 5, and we have plus 120 we can reduce with 2, so will be 10, so we have 1 over 10 integral of du over, when we factorize 4 we will have 4 times u squared plus 1. So now this is equal, we have 1 over 40 natural logarithm s squared plus 2s plus 5, and we have plus 1 over 10 times 4, so it will be 1 of plus 1 over 40. Integral of 1 over u squared plus 1 is equal arctangent of u. So I have to add constant. So this is equal, u is equal, we have s plus 1 is equal square root of 4 plus u. So we can write that u is equal s plus 1 over 2. So we have to copy 1 over 40 natural logarithm of s squared plus 2s plus 5, plus we have 1 over 40 arctangent of s plus 1 over 2 plus constant. This is solution for our first integral. Now we have to solve the second. We have to do the same operations. So first we will find derivative of denominator, s squared minus 2s plus 5, derivative with respect to s. So this is equal to s minus 2. Now we will divide our numerator by derivative of denominator. So we have, and I make mistake because d is equal 1 over 10, not 1 over 20. So here I should have to put 1 over 10. So now we have to divide numerator by derivative of denominator. So we have negative 1 over 20s plus 1 over 10. We have to divide by 2s minus 2. Negative 1 over 20s divided by 2s is negative 1 over 40. Negative 1 over 40 times 2s is negative 1 20 s times, and we have negative 1 over 40 times negative 2, so it's plus 1 over 20. Now we have to subtract, so this is equal 0, and we have 1 over 10 minus 1 over 20, so we have to multiply this expression by 2 to have the same denominator. So we have 2 over 20 minus 1 over 20, so it's 1 over 20. So now we can rewrite our integral, our second integral. This was a solution for our first, and now we solve second integral. So we have integral of, in numerator, we will have negative 1 over 40 times 2s minus 2 plus 1 over 20. If you do multiplication and you add 1 over 20, you will get exactly the same expression which we have here. So denominator, we can rewrite, so we have s squared minus 2s plus 5. We have integral with respect to s, so this is equal. Now we can rewrite this fraction, and we will have that this is equal integral of negative 1 over 40 2s minus 2 over s squared minus 2s plus 5, and we will have plus 1 over 20 s squared minus 2s plus 5. So we have integral with respect to s. Integral of sum is equal sum of integrals, and we can put this constant and this before integrals, so we will have negative 1 over 40 integral of 2s minus 2 over s squared minus 2s plus 5 with respect to s, plus 1 over 20, of course, integral of 1 over s squared minus 2s plus 5 with respect to s. So this is equal. In first integral, we have derivative of denominator in numerator, so this is equal. We have to copy negative 1 over 40 natural logarithm of absolute value of s squared minus 2s plus 5. And constant we will add at the end, plus we have 1 over 20. And now we will rewrite our denominator in the second integral, 2s minus 1 to second power. It will be s squared minus 2s, the same what we have here. And we will have plus 1. We need to add 4 because we have 5 here with respect to s. So this is equal. We have negative 1 over 40 natural logarithm of absolute value of s squared minus 2s plus 5, because we found at the beginning that this delta for this expression, quadratic expression, is less than 0, so we don't have roots, and coefficient before s is positive, so it means our parabola is opened up as is and is above x-axis, so it doesn't have negative values, so we don't need this absolute values. We can write this expression in parentheses, so it will be s squared minus 2s plus 5, plus we have 1 over 20, and now we will substitute s minus 1 by square root of 4 plus u, because we need to reduce this 4 to 1. So let me put this here. We will have s minus 1 is equal square root of 4 u. Now derivative of both sides with respect to s, so 1 is equal to du to ds. So we have that ds is equal to du. So we have now integral of 1 over square root of 4u to second power plus 4 with respect to s. So this is equal, we have to copy first expression. We have negative 1 over 4e natural logarithm of s squared minus 2s plus 5 plus 1 over 20, and we have integral of 1 over square root of 4 to second power, so it will be 4u squared plus 4 times ds is 2 du. So we have 2 du. 2 we can reduce with 20 will be 10. And now we have that negative 1 over 4e natural logarithm of s squared minus 2s plus 5 plus we have 1 over 10, and we will factorize 4 from denominator, so it will be 1 over 10 times 1 over 4, so it will be 1 over 4e integral of 1 over u squared plus 1 with respect to u. So this is equal negative 1 over 4e natural logarithm of s squared minus 2s plus 5, and we will have 1 plus 1 over 4e. Integral of 1 over u squared plus 1 is arctangent. And we have of u, but u is equal, we can find from this expression that u is equal s minus 1 divided by 2 plus constant c. So now we can rewrite our solution and put together this two. So first solution for the first integral is 1 over 4e natural logarithm of s squared plus 2s plus 5. We have plus 1 over 4e arc tangent of s plus 1 over 2 plus constant. We can put c1 here and c2 here. And we have minus 1 over 4, the second solution, negative 1 over 4 natural logarithm of s squared minus 2s plus 5 plus 1 over 4 arc tangent s minus 1 over 2 plus c2. So this is equal, we can factorize 1 over 4e, and we will have in brackets natural logarithm, and we will have minus natural logarithm. So we will use property of logarithm and rewrite this, that this is equal natural logarithm of s squared plus 2s plus 5 over s squared, we have minus 2s plus 5. And next we have plus arc tangent of s plus 1 over 2 plus arc tangent of s minus 1 over 2, close brackets, and we can add constant c. This is my solution.